Hi, it's Moser with a quick tutorial on relating empirical and molecular formula through molar mass. After this video, you should be able to use empirical formula and molecular mass to find the molecular formula for any compound. So you need to already know the difference between empirical and molecular formulas, as well as how to calculate formula mass. So just as a quick refresher, remember that empirical formula is the simplest ratio of atoms that forms a compound. And when we're talking about molecular compounds, the molecular formula may be different because the molecular formula gives the exact number of atoms in a molecule of the compound. So for the empirical formula CH2, we have multiple possible molecular formulas: C2H4, C3H6, C4H8, and so on. The question is, how do these relate mathematically? Well, it's as though there was some multiplier, and we could use that to multiply by each of the subscripts in the empirical formula, and it would give us the molecular formula. Okay, I see a formula coming. So we could say that some number x, some multiplier value, times the empirical formula gives us the molecular formula. But it's not like you're really multiplying it by the empirical formula. And besides, that doesn't really help. But this does. It's also true then that that same multiplier x, when multiplied by the empirical formula mass, gives us the molecular formula mass. Now this is something we can work with. Let's try an example in sort of the forwards direction, one where we already know the empirical and molecular formula, and let's see if we can figure out what the multiplier x is. Well, we know that the empirical formula mass for this compound is 14.03 grams per mole, and the molecular formula mass is 42.09 grams per mole. When we divide the molecular formula mass by the empirical formula mass, we get a multiplier of 3. And sure enough, if we were to take the subscripts in the empirical formula and multiply them by 3, we would get the subscripts in the molecular formula. Awesome! And I should point out at this juncture that while we typically use the equation in a form sort of like this, we can really rearrange this to find any of the 3 variables. So here's the one that's most common and most helpful. X times empirical formula mass equals molecular formula mass. Rearranged gives us this. Once we have that multiplier x, we can actually do the math on the subscripts to come up with the molecular formula. So let's say that we're told that there is a compound with an empirical formula NO2, which has a molecular formula mass of 92.02 grams per mole. We want to know its molecular formula. Well, we know we're going to start with this equation, x equals molecular formula mass over empirical formula mass. And we know that we already know the molecular formula mass, but we need the empirical formula mass. N plus 2 oxygens gives us an empirical formula mass of 46.01. So when we divide those, what do we get? X equals 2. But that doesn't actually get us our empirical formula yet, does it? Nope. We now have to use that multiplier on the subscripts in the empirical formula. It's going to look like this. We'll write down our empirical formula with its subscripts. Note that I've put a 1 in there, even though we don't normally use those. And we're going to multiply each of them by our multiplier x. That gets us N2O4. That's easy. What about a case where we're given percent comp data and a molecular formula and asked for a molecular formula mass and asked for a molecular formula? Can you do that? Of course you can. Remember that with percent comp data, you find what? Empirical formula. Once you have the empirical formula, if you have molecular mass, you can use the empirical formula to find empirical formula mass, use the molecular formula mass and the empirical mass to find your multiplier, and you can get to the molecular formula. I'll do another video on this. For now, go ahead and practice some of these kinds of problems. Have fun!